All right, welcome back to lesson 2, manhole covers. So what are manhole covers? Well, manhole covers are heavy removable plates. I'm sure you've seen them everywhere. They're used to cover maintenance holes in the ground. Now, I never knew they were called manhole covers, but that's apparently what they're called. Most manhole covers are circular and can be found all over the world. The top covers of these can be plain or have some, it says beautiful designs. I think they're more like interesting designs cast into their tops. Now, why are we talking about manhole covers? Let's click next here. We're going to be continuing our topic on circles. So the vertex of an angle can be located anywhere. Last lesson we talked how it could be on the circle or at the center. So here it says they can be located inside, at the inside of a circle, outside of a circle, or on a circle. In this lesson, you will explore these locations and prove theorems related to each situation. So question number 1. It tells us, here we have circle O. Remember, we named circles by the center. So this is circle O. It shows a simple manhole cover design. It says that the measure of arc, represented with that curvature above the two letters B and D, is equal to 70 degrees. Remember, last class we learned how to measure arcs, and so this one is 70 degrees, and arc AC is 110 degrees. Consider BED, angle BED. How is this angle different from the angles that you have seen so far in this chapter, and how is this angle the same? So go ahead and pause the video and just kind of ponder. How do you think that this is, maybe you can go back to your notes to see what you see that is different or similar to this angle BED. So if you paused it and you came back, perhaps you typed in this box that you notice that this angle is different from the previous angle in a way that because the vertex of this angle is neither on the circle nor on the center of the circle. The angles are the same in the way that the endpoints of the sides of the angle lie on the circle. So that are the similarities and differences. So you can see that the vertex is somewhere inside the circle, but not specifically at the center or at the edge. But the angle itself looks very similar to what we've seen before. So hopefully you were able to type that in. Now, what do you think? Do you think that we'll be able to determine the measure of this angle with the information that we have so far? So pause the video and see if you can figure out what the measure of this angle is. And you would have to go back and review this picture. So do you think we have enough information? Take a moment and think. Well, if you said no, you are correct. We don't have enough information to determine the measure of angle BED. And so we would have to see what else should we know to be able to say what the measure of that angle is. Oops, I pressed the wrong button there. So now we get to our question 3. Our number 3 tells us to draw chord CD. So remember what a chord is. A chord is a line segment inside of a circle. So what we're going to do is I'm going to take a screenshot, and you can do the same. Take a screenshot so we can draw chord CD. And now I'm going to go to my photos. Click edit. And there goes my phone. More like my computer. Let's try this again. Okay, that means I'm going to have to close it and open up. If that ever happens, just close it up and open it back up and see if it'll work the second time. Yep, there it is. Okay. So let's go ahead and use the ruler just so that it looks neat. We're going to draw a line segment connecting C to D. And that's it. Click done and done. And you can upload that picture into Canvas. You would click Browse, and you should be able to upload it. Moving on to question 4. It tells us to use the information given in the figure to name the measures of any angles that you do know. So that means we should have enough information now to be able to answer this. So what should we do here? So let's go back to our picture. We're going to use information given in the figure to name the measures of any angles that we should know. So let's go back to our picture. And let's see here. The chord CD is constructed like how we did, so from point C to D. The known angles, the known angles are angles B, C, D. I'm going to go ahead and highlight them so you can see exactly what I'm talking about. So we should know the measure of the angles of B, C, D. B, C, D. We should be able to know the measure of that angle based on what we've known or what we learned from the previous lesson. And the measure of angle ADC. A, D, and C. So we should be able to know the measures of those angles. Can you remember the name of those angles from last class? The vertex is on the circle. Yep, that's correct. If you said inscribed angles, that is correct. And remember, last class we learned that inscribed angles measure is equal to half of the measure of the intercepted arc. Remember the football analogy. So if we already know, they told us that the measure of BD is 70 degrees and the measure of AC is 110 degrees. So therefore, we know that the measure of the angle right across from it, this angle right here, BCD, should be half of the measure of that arc. So what is half of 70? If you said 35, that is correct. So that is the measure of that, that inscribed angle. And you can be typing this in. You can say the measure of angle BCD is equal to 35 degrees. Likewise, we can do the same thing for our other angle. Let's keep this green one is the one we're looking at, the green angle. We know that the intercepted arc is 110. Remember, if they give you the arc, you should be able to find the measure of the opposite angle, this inscribed angle. So if we go down to the angle, it should be half of the measure of the arc. What is half of 110? If you said 55, that is correct. All right, so you can go ahead and type that in. Moving on to question 5. It says, how does the measure of angle BED relate to triangle CED? So let's go back to our picture and see if we can find how those two are related. How does angle BED relate to the triangle CED? So let me erase some of this information. So let's highlight what it's specifically talking about in this question. So how does the measure of angle BED, this angle BED, relate to the triangle CED? So let's highlight triangle C to E to D, CED, this green triangle. How do they relate? Well, we can see that the angle AEB and angle CED are vertical angles, right? We can see that this, I'm going to draw a little arc to show that this angle is opposite that one. And we learned last semester that angles that make an X like this are vertical angles, okay? Because they're across from each other. If they're across from each other and they form vertical angles, that means that they're equal. We also learned that comparing the yellow angle with the triangle here, we also learned that any angles that look like this are called supplementary angles, and they add up to 180. So you could type in any of the information I just said. We can say that angle BED and angle DOC are supplementary. Okay? They add up to 180. So that's some observations using information we learned from last semester, I mean. Moving on to number 6, it says, well, tells us to write a statement showing the relationship between the measure of angle BED, EDC, and ECD. What is the relationship that we can notice when we look at all those 3 angles? So let's go back to our picture. And I'm going to go ahead and erase some of this so we can see exactly what it's talking about. So let's trace the measure of angle BED. Then we're going to trace the measure of angle EDC. I think they mean DEC. And ECD. Let's erase this. Okay, so once again, let's keep that triangle that we had previously. Voila. All right, so they're asking us for what is the relationship between angles BED, EDC, and ECD. Okay, there's a typo here. They're actually asking for all the measures of the interior angles of this triangle. Okay, so instead of it being, the first one being BED, I believe they're asking for, let's see which one. BED, I think they're asking for CED instead. CED, and they put BED. Okay, so that's a typo. So they're wanting to know the measure, what's the relationship between CED, that's this one, the measure of EDC, that's this one, and the measure of ECD, this one right here. Okay, so just ignore that typo. It's instead of BED, it's CED. And we know the measure of all the relationship of all these angles because we learned last semester that inside of a triangle, all of the angles inside of a triangle add up to what number? If you said 180 degrees, that is correct. So you can type in that the measure, they all add up to 180. Okay? All right. Question number 7. It says, what is the measure of BED? What is the measure of BED? And I just want to make sure it's asking the one that we actually need it to be. So we're going to go back to our picture, and they're wanting to know the measure of EDC and let's see here. Yep, so instead of, once again, instead of the BED, I think they're asking for the measure of CED. Okay, so let me erase these. Oopsie. Let's keep the triangle. And they want us to find the measure of this angle right there. Well, if we know that the measures, all 3 measures of angles add up to 180 degrees, and we figured out already that this was 35 degrees from the previous sections we just answered, and this was 55 degrees. Remember, we talked about the inscribed angles? Well, if they all add up to 180, we know the other 2 are 35 and 55. We can figure out the measure of that missing angle, right? we could add 35 plus 55, and it gives us 90. And then we can subtract it from 180 because all three angles add up to 180. Subtract what we know, which is together they add up to 90. So 180 minus 90 gives us 90. That's what's left over. And so therefore this angle right there is a 90-degree angle. Okay, so that's your answer. Remember, there was just a typo. Please try not to get confused. Instead, they're not asking for BED, they're asking for CED, and so that angle is 90 degrees. Okay. Moving on to number 8. So number 8, this is the last one, and we're done with this section. 2.1. It says it appears that the measures of an interior angle in a circle is equal to half of the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay? So, basically what we learned, so let's go back to our picture and mark it up so we can fully understand this. So I'm going to erase this extra information so that you guys can figure out here. We came up with the rule. Remember, our goal was to find the measure of this angle, right? We didn't have a way to figure out what the measure of angle BED was. But we were able to find that the measure of this angle right here was 90. We used inscribed angles to do that, as well as a triangle to do that. Well, if the measure of that angle is 90, and remember we learned that if there's an angle that looks like this, that they add up to 180, so therefore this angle next to it would also be 90, right? Because they have to add up to 180. And so now we answered the question. BED is 90 degrees. And if that's 90 degrees, the one across from it would also be 90 degrees because they're vertical angles. So all of these angles inside of the circle happen to be 90 degrees. Now look at this. This is what we came up with. It appears that the measures of these two arcs right across from this angle BED, okay, is equal to half of adding the two arcs separately. So let's try that. Remember, this one was 110, they said, and this is 70. Let's add those two numbers together and divide by 2 and see what we get. If we add 110 plus 70, we get 180. If we take 180 and we divide it by 2, we get 90. So the point is that we learned today that the measure of these interior angles, it says it appears that the measures of these interior angles is equal to half of the sum of the intercepted arcs. Okay? So the arcs, we add the arcs together and we divide by 2 to get the measure of those interior angles. So go ahead and you would, after marking up what I just did, upload that picture. But I just want to give another example so this can really be honed in. And I know this is a longer video, but bear with me. I just want to make sure you guys fully understand. So let's say instead this is not what we have. And let's say that instead we have this to be 100 and over here this to be, let's say 50. These arcs, this is 100 and this is 50. And the question is, what's the measure of this angle right here? Right across from those intercepted arcs. If we know that, all we have to do is, based on the rule that we just discovered, all we have to do is we add the two arcs. That would give me 150. And then we would have to take the 150 and divide it by 2 to get our answer. So 150 divided by 2 would give me 75. And so the measures here would be 75 and this is 75. Now, if they ask you for this one, remember that 75 plus what would give you 180, because remember they make supplementary angles. These and this one, those two form supplementary angles, and so you could say what's 180 minus 75, and that gives you our answer here. That would be 105 degrees. So that once again, the point is you take the arcs, you divide by 2 to get the measure of the angle. If you need to find the other one that's not right across from those arcs, you would have to subtract from 180 from the number that you have. I hope that helps. I'll see you in the next video.